My name is Saroj Yadav. I am a software development manager with AWS Glue. Here I have my dear colleague, Jack Mitchell, who is big data architect with AWS Glue and AWS Lake Formation. So we have really two exciting innovations from AWS Glue that we are excited to share with you. Before I get started, a quick survey with a raise of hands. How many of you are familiar with AWS Glue or have used Glue before? Great. You are in great company because we have hundreds of thousands of customers using AWS Glue across 25 global regions of AWS. They trust AWS for their production data integration workloads. We have customers from a variety of industries, from consumers to financials to life sciences, and many more. So thank you for trusting AWS Glue for your production workload. We love to innovate, we love to reinvent, and we love making AWS Glue work better for you every day. We have a lot to cover, so let's get started. Today, you're going to hear about three different things. One, what is data integration? How does interactivity play a role in more effective data integration? Second, two key innovations from AWS Glue, which will make you much more productive. And finally, Zach will show you how you can build powerful data integration applications on top of AWS Glue. How, with an interactive Spark environment, you can unlock new use cases for your data integration. So before we get started, let's first look at why customers do data integration. So businesses rely on their data to make meaningful business decisions to move their business forward. Since data integration is a crucial process of analyzing your data that's spread across data silos, of looking at that data together with your teams so that you can make more effective business decisions. So that's why data integration is a really critical part for businesses because it helps them move forward. As I said earlier, we have hundreds and thousands of customers trusting AWS Glue for their data integration. And there are a few key reasons why they trust AWS Glue. First of all, it's serverless. Businesses want to be in the business of focusing on their own core values. They don't want to be in the business of running infrastructure, managing servers, managing capacity. AWS Glue does it for them. So that's one of the key reasons. Another reason is AWS Glue has a serverless execution engine that scales with their growth. It supports a variety of workloads. You can have streaming jobs, you can have interactive jobs, you can have batch and micro-batch jobs. It's open. So whatever code you write in PySpark, Scala, you can take it with you and you can run anywhere you like. There are absolutely no lock-ins in AWS Glue. And finally, it lets you do your data integration faster. Customers have data sources that they want to connect so that they can build maybe data lakes or data warehouses. AWS Glue has a rich ecosystem of connectors and marketplace so that you can pick a data connector that's well-suited for your needs so that you can get started as soon as possible. We have built-in transformations. If you like, you can bring your own transformations for your data needs. So it lets you integrate your data much more effectively and at a faster speed. So these are the key reasons why we see hundreds of millions of jobs running every day on AWS Glue for our customers. So this is great. But before we start looking at the need for interactivity, the role it plays, let's quickly look at what is data integration. So at a higher level, you have data sources that you want to discover, that you want to connect. Then you want to cleanse your data, transform your data, normalize your data so that you have the quality that you need in your data, so that you can build this quality, take this quality data, build data lakes. Once you have that, then you want to do data analysis on top of it. You want to maybe run your machine learning models on it. Maybe you want to build other data applications on top of it. So data integration is a complex part. And there are different components that make it complex and challenging. So let's take a quick look one by one and how it can be done better and more productive for you. So first of all, data. Data is huge. Data is growing at an unimaginable rate. There are new kind of data that's showing up every day. And you have different kind of data sources. Now, when customers, they start with their data integration process, they want to explore this data. They want to look at what is the structure of this data. They want to try some transformation, look at how the target data looks like. And then they try more transformation, some normalization, some cleanup. And every stage, they want to look at how this data, target data looks like. So how they do that now? Today, you have different kind of users. You have business analyst, which defines the kind of analysis that needs to be done. Then you have data engineers. They take these rules, they write code, then they run it on a sample data on a non-prod environment. They wait for the validation. If there are any errors, they go back to step one. Then if they want to try a series of transformation, write that transformation, run it in a non-prod environment, look at the target data, and so on for each transformation. So it's very iterative. It's very slow. The feedback mechanism is very poor. It comes too late. Meanwhile, if your rules of analysis have changed, you are back to square one. So it's very slow and lengthy. It's very iterative when it needs to be interactive. Imagine if you can just look at your data sources interactively, look at their data structure, look at the sample data right away interactively, try these transformation. Whatever your workflow is, whatever tools you are using that, you can do data exploration, visualization at each step. It's going to be a much more productive exploration. Then, second thing is different users. So unlike before, where a select group of users or central teams which used to do data preparation, data integration, now businesses, there are a lot of different kind of users who want to do this data preparation. And each of these users have different personas, have their own journeys, experience that they expect for their own choice of tools. They want to do the interactive data integration with their own choice of tools. Now you have different kind of users. First of all, you have users who prefer no-code solutions. These are the users who might prefer something like an Excel kind of a solution, where you look at your data, visualize your data just like in an Excel system. You apply pre-built transformation, and once you are happy with it, you get started with data integration. Second category is you have users who prefer drag and drop kind of a system. And while they are building the workflow with a drag and drop system, they want to preview their results, their intermediate stage results, as and when they are building the workflow. Then you have another data engineers who prefer, these days they use notebooks. So they interactively explore the data using notebooks. They try their data integration workflow using notebooks. Once they are happy with it, then they take it to the serverless Glue execution engine for the job execution. This is great. This is the interactive experience we are thinking about. But if you look at it, it's a disjoint experience. You are using one tool for your job authoring while you are using a separate execution engine for the execution. Then finally, you have advanced users. These are the users who prefer to use their own IDEs. They prefer to use their own infrastructure that is set up by their organization, and they want to do data integration using those tools. So you have need for interactivity in data. You have different user personas who wants to do interactive data integration and who would like to use tools of their own choice. So we have talked about data, we have talked about users. Let's talk about applications, which is a third dimension which makes data integration complex. So applications are getting pretty advanced these days. They want to react to events in real time. So there's a need for reactive apps. Customers, organizations, they want to build reactive apps for their own setup, whether it's on-premise, on cloud. They want to have their own custom setups for interactive data integration. And they want to build it at the right price point and a system that scales with their growth. So these are the three different dimensions that make data integration complex and where users can be more productive by adding the interactivity to it, right kind of interactivity. So if interactive data integration is so important, how do people do it today? So today, they have long-running Spark clusters. So there is a complex setup, there is a complex installation. By the time they are done with the setup, it's already 10 to 30 minutes, which means the first time to query is more than 30 minutes. Since these clusters are long-running clusters, there is no cost controls built in. So if your users are not using that cluster, there is a concern for cost overruns. And to avoid that, many times users have this out-of-band lifecycle management for these sessions. Finally, you have a noisy neighbor problem. Typically, these clusters are big clusters which are shared by other users. So you don't get that predictable performance because at any point, you are sharing those resources with other users who are running their own sessions. So we looked at the setup, we looked at the process. In summary, it's slow, it's lengthy, it costs users more, and it works for certain kind of users, if at all. So I'm thrilled to announce AWS Glue Interactive Sessions. It's rapid, it's cost-effective, and it works for you. So I want to take a pause here, and I want to share that you can have a serverless Spark environment with AWS Glue Interactive Sessions in a matter of seconds. It has cost controls built in, and it works for IDEs for tools of your choice. So let's take a closer look at each of them. It's rapid. So as I said, you have serverless Spark environment running in a matter of seconds. Any customization, any installation, you can do in seconds. This also means that you can run your first query in a matter of seconds. It's really rapid. On top, each session runs in its own dedicated resource. This means that not only a single user can run multiple sessions in parallel, but you can have multiple different users running their parallel sessions without impacting each other. Each session is going to have predictable performance because it's running on its own dedicated cluster. This is awesome. AWS Glue Interactive Sessions is frugal. If you are not running your session, then we auto-terminate it for you. You can configure your own default timeouts, which works for your own applications, for your own setup. Just like AWS Glue Jobs, this is pay-as-you-go. And unlike before, you get per second billing with 1 minute minimum billing. This is a huge savings for our customers. Finally, AWS Glue Sessions is easy to use. You will hear from Zach. He will show you a demo how AWS Glue Interactive Sessions can be used by different user personas with choice of their tools. How advanced users and organizations can build powerful interactive data integrations on top of their own custom setups. And it's backed by the same serverless execution engine as AWS Glue Jobs. We have hundreds of millions of Glue Jobs running every day. Interactive Sessions is going to be using exactly the same engine behind the scenes. It is scalable because it's built with that architecture in mind. We have different components that work together to scale it for your jobs, for your interactive sessions. When a job is submitted, it's received by a job manager. We split the job into stages. We process data in partitions in parallel to give you maximum throughput. As and when your job scales, we scale the number of tasks that are running in parallel. Each of these tasks gets scheduled on a worker. So as your job grows, as your data grows, we scale the underlying compute that's needed to finish execution for your job. So interactive sessions, they use exactly same serverless execution engine that's used by Glue 2.0 and Glue 3.0 jobs. And it's RESTful. It has APIs, which means you can build your own kind of applications. So let's hear from Zach a little bit what's underneath these APIs and how different kind of users can use interactive sessions really easily with their choice of tools.
Thank you, Suraj. So let's get into interactive sessions. Let's get into the guts, the meat. What is actually inside this thing? As Suraj said, interactive sessions is built on the same execution engine as Glue 2.0 and 3.0. What that means is you get the exact same instance, the exact same cluster, that exact same performance. Now, when you want to start a session, you simply create a session. The request is sent over to Spark to start a Spark cluster, a virtual Spark cluster. Once your driver's up, you can submit code that is obviously submitted to the executors. When that code is complete, you can fetch the results with another fetch API. And then, of course, the output is returned to your application according to your desire and your designs. It really is that simple. Create session, run statement, get statement, and stop session. It's really all you need to effectively manipulate Spark from anywhere and everywhere you might want to do so. But we didn't want to stop here. If we stopped at an API, it would be useful. You could integrate some wonderful applications. You could build some nice dashboards. But we wanted to go further. We wanted to take the thought of interactivity farther and closer to the user. And so we built on top of interactive sessions a Jupyter kernel. And so with interactive sessions for Jupyter, the kernel is open source. You can install it from PyPy, change it to your heart's content, and use it to integrate with your favorite IDEs. The kernel works with Jupyter Notebooks, Jupyter Lab. It works with Visual Studio Code and JetBrains IDEs, including IntelliJ, PyCharm, and DataSpell. Configuration in interactive sessions is simple. If you're familiar with Jupyter and Spark Magic, then this will be right at home for you. It's configured with magics. The biggest reason for this configuration is your config stays with your code. Every time I execute this notebook, irrespective of from where I'm executing, it will be executed on the same hardware with the same configuration and the same libraries. Now I don't have to guess which config, which setup, which version of anything was used. It's all baked in right alongside my code. Within the first cell, I can specify any configuration I want for Glue, including streaming. I can use interactive sessions to interact with Glue streaming. I can configure Spark. I can set VPC connections. I can install libraries from PyPy and other Python repositories. And anything else you can configure in Glue can be configured via these magics. So let's get into a demo. We can talk theoretics all day long, but I think you guys would rather see it than talk about it. So if we could bring up that demo. Thank you. So here I have a Jupyter Notebook running on my local MacBook. This is connected to the Glue PySpark kernel. There is a Glue Spark kernel, and there is a Glue PySpark kernel, naturally. We support Scala and PySpark and Glue. We have a kernel for each. In this notebook, you will see a couple of things. I have configured two standard workers running on Glue 2.0 and US West 2. If I need to remember how to configure something, I simply run the help magic. And I get to figure out, okay, those are the configs I need in order to set up my Glue environment the way I want. The second I start running my code, it brings up Glue. Now, when you make a typo, which happens all the time because it's development, fixing it is simple. It's as simple as restarting the kernel or rerunning. That's it. I don't have to re-provision. I don't have to rethink about something. If I miss a VPC, if I miss a connection to a database, I don't have to tear down my entire development environment. I simply add the connection, restart the kernel, and run it again. It really is that fast. And within seconds, I'm back to running Spark. Now, for this demo, I pre-populated the notebook with code because I'm not here to discuss how to write PySpark. In this session, I'm assuming you know how to write PySpark. And so the purpose of this session is to discuss the interaction mechanism that is interactive sessions. One of the most interesting magics, one of the most useful magics certainly, is the SQL magic, letting me interrogate my data catalog in real time. If I don't necessarily know which table I'm looking for, but I know it's in a particular database, an example here, the COVID-19 database, I can go and I can list the tables within that database. And I can see, I know I want to go for county populations, so I have to go find it. And sure enough, there's the county populations table. So I can go ahead and select county populations, and I want to go get the top 10 most populous counties in this data set. So I'm going to go run a quick SQL query to show me the most populous counties in this data set. Now, while my SQL is correct, we can see that population estimates is not sorting correctly. As a matter of fact, I'm pretty certain it's sorting as a string. So we're going to really quickly create a dynamic frame out of that table, and we're going to print it the schema because we want to validate why it's sorting incorrectly. If I'm trying to get the top 10 most populated counties, certainly these smaller counties don't count. And sure enough, population estimates 2018 is a string. And so because we have a dynamic frame in Glue, we can go ahead and apply a mapping to fix that string and turn it into a long. Additionally, while we're there, we're going to clean up the column names because in Spark, you should not have spaces in your columns, and you should have columns that make sense. So we're going to properly integrate our data into our data lake. Once that's done, I can run a .show to validate what does my data look like? Is it what I'm intending for it to be? And sure enough, now I can see that yes, my column names are clean. My data is the way I want it to be. If I would like a tabular form, I can convert it to a data frame and run a .show. Let's remember dynamic frames have individual schemas per record. And so we show them as JSON because one record might differ from the next in schema. So we don't want to assume a tabular form if we can't assume your data is clean. If you know your data is clean, you can run a to-df.show to get yourself a clean table. Now that we have clean data, let's go ahead and select that data and start looking at it as we wanted to. Let's go look for that top 10 counties by population. So we'll just go run a simple SQL query. And now that we've corrected the column type to a numeric, we can see that we can actually sort the column. Cool, column is sorted. Now just to finish it off, we're going to write the data out to our data catalog in a new table because what good does any data integration do if I'm not putting my results somewhere? So I'm going to put it in my data catalog. And for good measure, I'm going to read back that data catalog in another cell just to verify that my data wrote correctly and I'm happy with it. Once I'm satisfied, we can call it good. Now, I can leave my session alone and it will time out after my set timeout, which right now I believe I have configured to 1 hour. However, if I want to stop billing immediately because I'm done, I can call stop session, Glue terminates all compute, and billing stops. This is a dramatic cost savings over the current dev endpoints that usually live for days, weeks, or months. Okay, back to the slides, please. Now, We didn't want to stop there. We built Glue Studio as a visual interface for ETL. Again, going back to Saroj's discussion, there are many personas that want to interact and integrate with their data. There are those who need to do things visually and prefer drag and drop and forms to fill out. There are others who naturally prefer code. We also understand, though, that not everyone who prefers code prefers to deal with their own setup, their own IDEs. There are some that just can't. You don't have control over the environment. You don't have something that's yours. For whatever reason, you want an IDE in the cloud. You want the interactive sessions experience in the cloud. Remember, Glue Studio gives you the benefits of rapid development, simple monitoring, the ability to use batch and streaming ETL, and doing all of this in one place. You don't have to go outside Glue Studio to gain all the benefits of Glue. So we thought, why should you have to go outside of Glue Studio to gain the benefits of notebooks? So we put it as a notebook in Glue Studio. Glue Studio notebooks are serverless. They're hosted right inside Glue Studio alongside the job system. Glue Studio notebooks are free, and they allow for one-click job creation and scheduling. So let's take a look. Let's go ahead and flip back to my computer, please. So if we open Glue Studio, this is the Glue Studio console. If we click on Jobs, we see Jupyter Notebook. Now, we can create a blank Jupyter Notebook and start from scratch. But since we just went through an entire exercise, let's not do that. Let's upload an existing notebook, and we'll upload that population estimates notebook we just worked on. Now we're going to give the notebook job a name, and we're going to give it a role, and we're going to spin up a Jupyter Notebook. Within a few seconds, Jupyter will be popped up, and we will be able to interact with our data right inside Glue Studio. Now, as you can see, this is the exact same notebook we just ran. However, if I'm going to turn this into a job, I probably don't want all of this stuff in here. So let's just go ahead and clean it up. I'm going to leave my magics because I want configuration. I can get rid of the help, that's unnecessary. Imports can stay. Show tables I don't need because that was exploratory, as was the initial select. My create dynamic frame I do want to keep, but I don't need to print the schema, as that's an action that would slow me down. Same with my apply mapping. I do not need to print the apply mapping. I do not need to show, so I can delete those. I do not need the select to validate, but I do want to write it out. And finally, I don't need to validate at the end. Once I'm satisfied with my code, we can go over to job details. You will see here an error warning or a warning message. In Glue Studio, when you are authoring a job with Jupyter, you configure your job via magics. Glue Studio will read in those magics and populate your job config from those magics, so that you, again, have your config sitting alongside your code in one place at all times. Now, additionally, we convert your code to a script. This is the same PySpark script that you know and love, and it is auto-generated every time you change your code in your notebook. Once you're satisfied, you can click Save, and you can run your job. We can then go to Run Details, and the job will execute. Back to the deck, please. Notebooks are great. I am an extreme fan of Jupyter Notebooks. I believe you can get more done, you can understand your data better, you can have a much deeper ability to quickly iterate and innovate on that data and to integrate multiple data sources. However, I also understand that most data integration is done in production. It's not done by a person sitting at a computer in a notebook. Instead, it's done by some process. It's done by some application that is built and tuned for your business. And so, with interactive sessions, we put the APIs first. We understood that there is benefit to having direct API access to Spark, to be able to manipulate and work with your applications from anywhere your application is running, as long as it has access to the AWS SDK and an internet connection. So it's worth pointing out, again, that interactive sessions works with Glue streaming. While I've not demoed it here, there are lots of really interesting things you can do with an interactive application connected to Spark streaming. And there's a lot of really interesting things we can do if we're going to extend applications into Spark. So let's take a look at one. Glue Data Brew. It was launched a few years ago. It is a visual interface for preparing data for machine learning and transforms. It is a visually rich system, giving you all sorts of statistics and transforms, and you get to see all of your manipulations in real time. Data Brew is powered by interactive sessions and has been since the day it launched. It was the first public-facing system that was using interactive sessions. But I don't want to just say AWS can build something on IS. The whole point is to enable you to go build something, to enable you to create something amazing for your business. So let's go demo what can be built. Can we switch back to my machine, please? So just to give a simple demo, I have a detect PII script, and I apologize that the previous run showed up. What the script does is it connects to interactive sessions. It queries the table I just created, and it asks me to validate whether or not PII detected by Glue's PII detection algorithms are actually valid. Now, what did it find? It says it did not find anything here. So there's no PII here. What about the next one? It says it's found a person's name. And it found it in county. Okay, so Calmet is a person's name. But it's also a county. So we really don't care. Same here. Boward is a person's name. No, that's not a county. So at this point, I've gone through enough of these, I can just say none. None of these have PII. And so my application connects it. This is a very simple and trivial application, but it highlights the power of interactive sessions. If I have a compute system at scale of thousands of nodes connected to incredibly powerful systems such as PII detection algorithms, the ability to feed those into an application so my end users can work with and manipulate those systems in real time at scale changes what you can do as an application developer. You're no longer working on slices of your data. You're not working on this portion that you collected back. You get to work on the whole thing. And that's an extremely powerful thing for your end users. Back to the slides, please. So just to summarize, we built interactive sessions so you could more easily, quicker, and more cost-effectively build and design Glue jobs, interact with Glue's serverless compute, and work with your data in an integrated manner. It does provide end-to-end data integration for both batch applications as well as streaming. It allows you to interact with Apache Spark using your favorite IDE in a completely serverless manner. You can spin up as many notebooks as you would like. Each notebook will have its own dedicated compute. When you tear it down, billing stops. And of course, the APIs are simple and elegant, allowing you to build interactive applications to integrate the power of Spark into your application without having to think about provisioning, maintaining, or monitoring Spark at all. So what will you build? Thank you.